Welcome to Module 5 of the No Code Blueprint, how to design your business logic. So in this module, we're really going to start getting into the meat of things, and we're going to be talking about designing your business logic, as I said. Now, books have been written and certifications produced on process design and definition. There are also a ton of resources available, and in this module, I'm going to focus on the basics of process definition so that you can use this as a tool to help you design great software. There is a resource at the end to help you go into a little more detail if you're interested in doing that. So, as I said, we're going to cover off process design, then we're going to spend a little bit of time understanding business rules, and then finally in this module, we're going to cover off what we call control structures. And this is essentially how you control the logic within your application or the software that you're writing. But more about that as we get into it. So from a process design point of view, why would you really want to design business processes? Well, there are several reasons for this. Firstly, it helps you as a no-code developer understand the business process and the challenge that you're trying to solve. And even when we talk about business process, it doesn't necessarily mean to, be in a business, but it could be anything in day-to-day life or problems you're trying to solve for consumers. And you'll see that when we look at an example a little bit later on. Secondly, it'll help your client or whoever you're writing the software for also understand this, because often this is not the case where the person you're creating the software for doesn't understand the problem or doesn't understand the problem they're trying to solve. So this makes sure that there is alignment between what you're doing and what the client or the end user is expecting from the software. Thirdly, it makes a real-world scenario or process explicit, as these things can often be locked up in a person's head or just happen organically. This really just gets it down on paper and makes sure that it's explicitly stated, this is how the process works. Number 4, it offers an opportunity to improve the process, either in the real world or in the software that you're developing, or both. So a really good chance to look back on that process and see if it can in fact be improved. Number 5, it can save you time and effort by ensuring that you're solving the right problem, and in fact solving the right problem in the right way. And then finally, it brings about an understanding and agreement amongst multiple stakeholders on the process and the challenge to be solved. So let's take a little example and understand what a process design would look like for making a cup of coffee. So we're going to start at the first step. We need to boil the kettle. The second step, we need to get a mug. The third step is we need to add 1 spoon of coffee. The next step is to add the boiling water. The next step is to add milk. Then there is a step to stir. And then the process ends. Now, this is a very basic example, and I'm sure already you've started to ask some questions around what happens if the person wants a stronger cup of coffee. I might want to add 2 spoons of coffee. What happens if the person doesn't want milk? I'm going to skip that step. What happens if I get confused and add the boiling water somewhere else because it doesn't specifically say put the boiling water in the mug? Now, I've done this on purpose to kind of highlight the validity and the value of doing something like this, because you get down to being really explicit about what problem you're trying to solve. So when you design a business process or write down one, these are the sorts of things you need to think about, and you need to be really explicit in terms of understanding how that works. Of course, there are much more complex processes. What you might even do is, if you look at the first step of boiling the kettle, you might break that down to, fill up the kettle first, then put the kettle back on its stand or whichever appliance you've got, and then boil the kettle. So you can see it really gets you thinking in terms of making sure you've covered all of those steps off that you really need to think about. So in summary, a defined and documented process is generally a visual representation of a real-world process. You can see in the previous slide, we just had a basic flowchart. That is, anything that happens in the real world. So there are several key questions that a well-defined process needs to answer, and these are, firstly, when the process starts. So in the previous example, it might have been when someone asked for a cup of coffee. Secondly, what those exact steps are in the process. Third, what the correct sequence of those steps are. So again, controversial. you might put coffee in the mug, and you might put milk in the mug, and then put the boiling water in, you know, which kind of would work. Or you might put the water in, stir, and then put the coffee in, which isn't really going to work that well. So again, making sure you've got the sequencing right is very important. Number 4, who performs each of those steps? So again, in our example, it was very simple. But in a properly documented process, you need to think about who will be performing each of those steps. Then, you know, number 5, what each step requires before getting started. So what are the inputs to that step? So, of course, the input into pouring boiling water into a mug was boiling the water in the first place. And then number 6, thinking about what each step will produce, which are the outputs. And then finally, when the process ends, because it can't go on forever. And you'll see that a little bit later when we look at some of the examples of control structures. So in a way, you can think of this as a recipe. You need the right ingredients, and you need to do things in the right order. For example, you would not warm your olive oil in a pan, pour it on a plate, serve the plate, and then dump the rest of the ingredients in the plate. You know, this might be obvious, but it needs to be made explicit. So you need to be really clear about who does what. It's a simple example, but I think you get the idea of thinking out a well-defined process. So what sort of approaches can we take to defining these processes or understanding the rules that we want to implement, understanding the challenges we're trying to solve? Well, there are several approaches that you can use to get to this point, and these are firstly and foremost interviews and workshops. And this is simply working with someone who either knows the subject matter or who performs or has performed the task or process in the past. Get the person to talk you through what it is they do, asking them questions, you know, who does what, when do they do it, what do they do, how do they do it, how does it work, all of those sorts of things. And make sure you understand what is being discussed by writing this down and playing back your understanding to that person. And taking that approach, you can get explicit agreement on this is the way the thing really works. Number 2, you can do this through observation, and you know, you'll use a similar approach to the above, but instead of asking questions, you're just going to observe what happens. So back to our example, watching someone make a cup of coffee. Thirdly, you can use research, and you can use a combination of online and printed material. You'll be able to understand and define a business process through this method. I'd only really recommend this approach if you can't do either one or two above, so the interviews or workshops or observation. However, you could also use this as a starter for understanding and documenting a process and then playing it back to stakeholders or potential users. So you can build a bit of a foundation doing some research and then delving into the specifics and validation. You can also use reference or best practice material, and this is similar to the point above. However, you'll use formally established reference material, and there are many of these reference or best practice models available. Some will be very specific to an industry, and others may be more general. A good starting point I found is the APCQ framework, and this is really a good approach when trying to design something to be used by many users in a corporate environment who might have slightly different requirements. And you know, using a reference or best practice approach can really set your software as the standard. If you're building consumer software, it's a little difficult because you don't really have some of those resources available. But again, it all depends on the sort of software you're writing and who you're writing that software for. Right, so how can we now put this into action? Well, having understood and defined the business processes that will inform the business logic of your application, you can implement these when you build your software now. So depending on the no-code platform you're using, the tools you will have at your disposal will vary. Some tools, such as Airtable, will allow you to build business rules or logic using formulas similar to Microsoft Excel. And others, like Bubble, will provide you with an experience that kind of mimics a process flow diagram. So when you start looking at the workflows in Bubble, they'll look very similar to the diagram you saw about making a cup of coffee. And then others will provide you this via configuration options. Finally, some, while being no-code platforms, will actually allow you to break out and write actual code. For example, WordPress, where you can write your own JavaScript or HTML. And this is where you will really need to invest the time to learn the specifics of your chosen platform. So whichever approach your platform uses, it's imperative that you understand the type of logic available to you. So in traditional program, these are known as control structures, which I mentioned a bit earlier. These may be labeled differently on your chosen platform, but any worthwhile platform should ever have an implementation of these in some shape or form. This is important because once you've designed your business logic, i.e. on paper, you will need to use one or more of these approaches to implement it on the no-code platform that you're building on. So let's take a look at what these logic structures or control structures look like. So these are the key ones I've listed out. And why are these important? Knowing how these work is important because 1, it'll help you build your business logic. 2, it'll help you do this in a robust way. And 3, it'll help you do this in an efficient way. So for example, to solve a certain problem, you can use one or more approaches, but some are more efficient and effective than others. And you'll see this as we go through the examples. So looking at these examples in a little more detail, let's start off with probably the most common one. And this is the one that you probably know the most because we use it in Microsoft Excel and other applications in a similar format. So simply put, this statement checks if something is true. So does it match some criteria you've laid out? And if it does, go ahead and do something. If it doesn't match that criteria, then do something else or do nothing. And this is best used when you need to choose or decide between 2 outcomes. For example, if today is the user's birthday, then send them a birthday message. If it's not their birthday, then do nothing. So this control structure can be used for more complex logic by nesting statements, but it does get a bit messy. So for example, if today is the 1st of January, send a Happy New Year message, or else if today is the 25th of January, send a Burns Night message, or else if today is the 4th of July, send an Independence Day message, and so on. So it does get a bit more complex and messy, and I'd kind of recommend not using nested if then else statements because there are better ways of solving that. So you can see in the first illustration there, that's what the Excel formula would look like. If you look at the second one, that's what the implementation would look like in Visual Basic. And then thirdly, it looks a little more complex in JavaScript. So not to say that you'll be using any of these per se, but just to give you an idea of how they work and how they look. The next one is a case statement, and this control structure provides a little more flexibility when you're testing or checking multiple conditions. So this would be ideal to solve our calendar example that we spoke about before, and it would be done in the following way. So you'd say, case date, when 1 January, then send New Year message, when 25 January, send Burns Night message, when 4 July, send Independence Day message, end. Or in the example we've got here, you can use it to decide which size category an article of clothing goes into. So essentially we're saying in the Excel example, if the value in cell F4 is S, so small, it goes into the category 36 to 38. If it is a medium, then it goes into 39 to 41 and so on. And you can see this gets a little quite complex because those are those nested structures that I spoke about. Although there is an alternate way to solve it using the switch statement in Excel. In Visual Basic, you can see actually, although this is coding, it's easier than the one done in Excel. And the same is true for the one in JavaScript on the right. So this is where these control structures, have that power and outshine things like Excel. Now, the next set of control structures are used when you want to perform something multiple times or keep performing something whilst the condition is either true or false. And this is the loop count one. So you would use this when you know the number of times you wish to repeat something. So for example, you might want to award a prize to the first 10 users who complete an online assignment. And it might look something like starting off with a completion set to 0, and while the completions are less than or equal to 10, award the prize, and then noting that your completions become your completions plus 1. So incrementing the count of people that have completed that activity that you're trying to measure. And note that after awarding the prize, we've increased the count by 1. And this means that once the 11th person completes the activity, the loop will stop because we don't want to award any more prizes. And this increment is very important because if you miss it, everyone will get an award in this example, and the loop just becomes infinite. And this could also cause your software to crash depending on the use case. There are another option you can use, which is the do, until, or while statement. And this is effectively the same as the loop count example, and the code will run until this condition you set is true. So again, you need to watch out for infinite loops. I've given some examples here, one in Visual Basic, one in JavaScript, and one in Python, just so you can see how those kind of compare to each other. Right, the last one we're going to look at now is the for each control structure or statement. And you would use this approach when working through a finite list of items. So for example, items in an array. So where a user might have multiple addresses and you want to send a letter to each of those addresses, or for a finite amount of records in a table, for example, for each customer. So your set of instructions would run for each item in the list, and you also need to remember to move things on, but ensuring that your logic moves on to the next item in the list or the next record. Otherwise, you're going to keep on applying the same logic to the same item. So in the address example, you might just keep on sending the same letter to the same address all of the time. And while some of these control structures or logic structures seem technical, they might not look exactly like this on your no-code platform, but it really is important to understand how they work so you can implement the necessary logic in your low-code or no-code applications. Right, then finally, if you do want to learn a little bit more about process design, there's a great resource on the web which you can link to, and the link will be made available in the notes. And then finally, what I'm going to show you is some examples in Airtable and in Bubble of how these control structures are implemented. So keep watching or keep looking at the next bit of the module, and these will really come to life in those no-code platforms. See you there.